Hi, this is the screencast for section 1.7 through 1.8. And before we get started, I just want to let you know that, um, like the multiple choice questions that we had before in class, your grade on all AP classroom assignments will be 75% of the point values in AP Classroom. So that's what I'll record in the grade book. So try to get everything correct, try to get 100%, but just know that the score that I record will be based on 75% of those points. All right, so 1.7 is on periodic trends. The learning objective is to be able to explain the relationship between trends in atomic properties of elements and electronic structure and periodicity. So the essential knowledge is we want to know about the periodic trends. Those would be ionization energy, atomic and ionic radii, and electronegativity. And then to explain the differences, we want to use the concepts of shielding effect and effective nuclear charge. You cannot use just the location of a couple of different atoms on the periodic table as an explanation. You want to use these concepts right here. All right, so we'll actually start with ionic radii. So if you have a neutral atom, to form a negative ion, electrons have to be added to the outside energy level. So that means that the electrons will spread out a little bit. So the net result is that negative ions end up being a little bit larger than their neutral atom. On the other side, when you have a positive ion that forms, you end up losing the outer energy level of electrons. So they end up getting smaller than their neutral atom. So positive ions are smaller, negative ions are larger. So that's the first trend that you want to know for ionic radii. Now, as far as the other ones, you want to know what happens for a group trend as we go down a group, and you want to know what happens for the period trend as we go from left to right across the period. So we'll start with ionization energy. So as we go from top to bottom, the ionization energy will decrease as we move down a group. The period trend for ionization energy, as we go from left to right, ionization energy increases. Okay. The next one is atomic radius, or the size of the atom. As we move down a group, atomic radius increases, and as we go from left to right, atomic radius decreases. The other one you want to know is electronegativity. And if you just remember the big kahuna, right? Fluorine is the most electronegative element. The trends for electronegativity don't include the noble gases. And electronegativity is just the tendency of an atom to attract a shared pair of electrons towards itself in a covalent bond. So fluorine has the largest electronegativity. So as we move down a group, electronegativity tends to decrease. And as we go from left to right, electronegativity tends to increase. Okay. Now for the explanations, you have shielding effect and effective nuclear charge. So when you're comparing elements in the same group, the go-to explanation is shielding effect. The shielding effect is that inner electrons will shield outer electrons from the pull of the nucleus. So as we move down a group, you're adding layers of electrons in between the nucleus and the outer electrons, so the shielding effect is going to increase. So if you're comparing, say, potassium to sodium, you would say the ionization energy of potassium is lower because potassium has a greater shielding effect. Now when you're going across a period, the go-to explanation is effective nuclear charge. So as we go across a row, you add more protons to the nucleus, but the electrons that you add are in the same energy level. So the effective nuclear charge is going to increase. So say we're comparing nitrogen to oxygen, you would say that oxygen has a higher ionization energy because it has a greater effective nuclear charge. Okay, and then the last section is 1.8, valence electrons in ionic compounds. The learning objective here is to explain the relationship between trends in the reactivity of elements and periodicity. The essential knowledge is valence electrons determine the types of chemical bonds, and actually Unit 2 has more on chemical bonds, so we'll talk about that more then. And ionic charge is determined by valence electrons, and the idea here is you want to get to the octet rule, or the rule of 8. So atoms will gain or lose electrons to get up to 8 in their outside energy level, and that determines the ionic charge. And then elements in the same column will form analogous compounds. So that means, for example, let's say we take calcium chloride, CaCl2. So if you take another element that's in the same column as calcium, say magnesium, magnesium would form a similar compound with chloride, so it would be MgCl2. And you'd also expect it to have some similar chemical and physical properties. Or another way to look at this, instead of chlorine, if you replace chlorine with another element in its column, another halogen, so say fluorine, so it would also form a compound like this. It'd be CaF2. So the fluorine CaF2 is analogous to CaCl2. So it's just saying that elements that are in the same column will form similar compounds. Right, and that is all for today. You have an assignment on AP Classroom. Have a good day.